Hi guys, Mr. G here, and welcome to Algebra. Let's look at one of these troublesome exponential equations. What I'm going to do first here, guys, is to write this equation in standard form such that I have 0 on the right-hand side. So if I write this in standard form, I'm going to have 2x plus 4 minus 12 over 2 to the exponent x equals to 0. Of course, even if you had a minus 12 here and a plus 4 there, it's really immaterial. Now, if I multiply every term by 2x, okay, let me write this in a different color. In other words, if I multiply this by a 2 to the exponent x, and this here by 2 to the exponent x, and this one here by 2 to the exponent x, what happens there, folks, is that I'm going to be left with 2 to the 2x. Maybe I jumped, I was 2 over there. So let me just write it and explain what's going to happen. Plus, I'm going to have 4 times 2 to the exponent x minus 12 equals to 0. Now, guys, I can simplify this. And then because I'm multiplying same basis, I add exponents. Plus 4 times 2 to the exponent x minus 12. And if you are wondering why I did not here write 4 as a prime base, because I can add, it's a very good question, okay? The reason I did not do that, because I want to see this as a quadratic. I want to see this entire thing as a quadratic. And you will see what I mean when I say you should see this as a quadratic. But never mind this question here, we're going to do it next. Now, if you look at 2 to the 2x plus 4 times 2 to the x minus 12. Something is common here, and it is x, or rather the exponent x and a 2. So if you look at this, I can actually rewrite this entire thing here as 2x, 2 to the x rather, squared plus 4 times 2 to the x minus 12. So let me keep my equation sign. And what comes out now, if you let 2 to the x to be any letter k, for example, so let 2 to the exponent x be k, then you realize you actually have k squared plus 4k minus 12. And this is exactly what we want. We can now actually factorize this, okay? So if we were to factorize this, we were just going to have, looks to me like we're going to have to get something like a 6 and a 2. So I'm going to have a plus 6 here, and then we're going to have k minus 2 as the factors of 12, by the way. So this is k squared minus 2k plus 6k will give me that, and this will give me a minus 12. So therefore, we know now the solution here is, well, either k is minus 6 or 2. Now I can substitute back. If I substitute back, I have 2 to the x is equal to minus 6, or 2 to the x is equals to 2. Now, we know once you get an equation like this, there is actually no solution in this case. Okay. I mean, first of all, 6 cannot be, well, 6 can only be written as 3 times 2. But the big problem that makes us to see that there is no solution is this negative here. Okay, right? You can go ahead actually and try and see if ever you will get something like this. As a matter of fact, you can solve this in terms of functions. You can test this in terms of functions, because there's an exponential function. If you do this and you're gonna, of course, add 0 there, when x equals to 0, you're gonna have 1. So this graph is gonna pass somewhere here. So question is, at what point is this graph going to touch minus 6 on the y-axis? You can see clearly that's not gonna happen. So that's why there will not be a solution. But we can see this point we can see actually that this graph here, when x equals to 1, look at that. When x equals to 1 is actually going to be at 2. So we can see that this will be a 2 if x, if x equals to 1, this is x equals to 0. If x equals to 1, so we said that's a 1, so 2 will be somewhere there. So sketches can also even help you, to get a clear sense or a clear picture of what goes on in these equations. Actually, algebraic equations are a representation of what what we do every day, or somehow. Of course, some of the things we do every day are very complicated to be represented by an equation. Okay, so let us look at the second problem, the last one for this video. You have to show that this thing, you will pardon me, this question is incomplete. So I'm actually going to cut the video now and bring a complete question. Okay, cheers.